Next up, we have Fastackl here in the chat. A presentation on NFTs using IPFS. I'll let them give the introduction that I cannot. More than welcome to start your presentation when you're ready.
Great meeting you, Luke. Thanks a lot. Do you mind if I share screen?
Go for it. Go for it.
So it's telling me here you cannot start screen share while the other participant is sharing. Oh, here we go.
There we go.
Great. Yeah. So thanks, Luke. Great meeting you. Yeah, today, so we launched a protocol on Wednesday called KSPEC. So this presentation has come together pretty quickly, sort of hacked it together overnight. Before we jump in, I'll just give a very quick background on myself and the collective that I'm contributing to. Since March, well, from the very beginning, I've been contributing to this collective called Kanon, which is a group of senior museum curators and conservators who are operating pseudonymously. So they all sort of work at the top art institutions of the world. And then a few of us are also technologists and with background in crypto degens, basically sort of React engineers and Solidity engineers. Myself personally, I'm not an engineer, but I've spent a lot of time sort of developing software products and sort of semi-proficient in in Node, but also a very avid NFT collector since about December. So very briefly, I topped the charts in super rare until the real whales started. The actual real whales started moving in around January was when it really started taking off. But the protocol that we've developed really came out of the sort of the issues that I was seeing in my own collecting. So when I started collecting, I found myself developing very close and fun relationships with a whole bunch of NFT artists, and we were running up into a lot of constraints and insatisfactions with the way that these NFTs are structured. So KSPEC is, first of all, it's open source, it's permissionless, it's completely on-chain. And what it does is it gives artists unconstrained freedom to create. So we'll go into some of the most common constraints that they end up encountering. And then for collectors, so for people like myself, also, these things, I made the mistake very early on of peeking under the hood, and there's some real serious issues there in terms of how long these things will actually last, and also provenance is very brittle, which we'll get into. And then for NFTs, the protocol gives them adaptability and updatability. So normally NFTs, as many of you might be aware, they're immutable, both at the token level and also at the contract level. So the protocol gives the artwork that these artists are creating updatability and adaptability. So the protocol actually works with any NFT. So this is super important to me because I spent an irresponsible amount of ETH on NFTs. So this protocol works with any NFT, even if they've already been minted. And there's no need to stake or burn or otherwise encumber your NFT. It's non-invasive. As I said, we launched on Wednesday, and I thought, when we were putting this together, I had an inkling that this might be big, and I'm getting more and more conviction that actually this is a game changer for NFTs. Diving into what the actual problem was that we were looking to solve. A lot of you might be familiar with this, but I'll just go through it just to make sure that everybody's aware as to how these things work. At the low level. So typically an NFT, is a smart contract, and there's thousands of these that have been deployed, and each one of them So say the structure of an ERC 721, which is the most common standard. It's effectively, you can think of it as like a table with rows, and each row is a token. And tokens have a token URI property that then returns a single link. Or you can also pass like bytes, or the token URI can respond with a package of bytes, but effectively it's just like a static response, text string response that is returned by the contract. And then it also tracks, an address, right, that controls the ownership of each token. So that's at the contract level. And practically, the way that platforms implement the contracts is, if you're an artist and you want to create an NFT, you put a file. Best practice, obviously, save it on IPFS. Sometimes, or you can return bytes directly. So, because obviously that's on chain. But for practical purposes, the platforms restrict what you can upload. This is rareable, so it's 100 megabytes, super rare. We're restricted to 50 megabytes, and crucially, it's generally just one file that you can upload. So basically, an NFT at the moment, if you're trying to create an NFT and you're trying to create art, you have to squeeze everything into a single 50 to 100 megabyte file. So when you're trying to do that, that really chokes creativity. And one thing that, for me, because I'm not from an art background, the very first NFT that I collected was the very first piece of art that I collected. That was in December 2020. And what took me a bit of time to realize, and then obviously working very closely with these museum conservatives, is that digital art has been around for decades, right? And artists have not been facing, they don't face constraints when they're creating. So for them, it's really torturous to have these wonderful creations and then having to try to like jam it into a single megabyte file. So that ends up meaning that, for instance, like this anima music video, normally the artist is working in ProRes. Or 4K, and those files are, this file is actually 4 gigabytes. And so, how are you going to squeeze that into 50 megabytes? Well, you're facing the choice of either really degrading the art, degrading the resolution, or clipping the length, or both. Which is just awful, right? So you can serve the file offline, but then it's not connected to the NFT. So that's probably the most common limitation that I encountered in my own collecting, and also that I hear artists most frustrated by. But then actually, in the real world, art is actually often more complex than just a single file. So, for instance, this is an art piece by an artist called Rachel Rose, which is actually a multi-part installation. So, how do you represent something that's like got multiple parts in an NFT? That's very challenging. And then, with an area that's particularly of interest to me, given I really love these. So like 3D avatars, these. It's basically the 3D at the moment is in a very nascent stage. So the ecosystem's evolving very rapidly, and the formats change. And as an artist, it's very risky, right, to commit to any particular format because. Right now, sort of GLBs, GLTFs, are the formats, but even those have like all sorts of variations that change over time. So if you have to commit to a file up front and then you can't update it, you're not going to stick it into the NFT. So some of the solutions that you're seeing are off chain, like in Meebus, for instance. This is just coming off their own server. There are some hacks around it, but you can see here, this is to me, at least when I see this is Sir Tim Berners-Lee NFT. So sometimes solutions that people come to is like try to jam everything into the description field of an NFT, but even this you can't change subsequently. So our the solution that we came to. By the way, this is a problem that's very well understood, and there are some solutions that a lot of the solutions that we've seen are sort of hacks, right? Like this one where you try to jam everything into a description. The other one is like trying to attack the problem at the smart contract level. But the problem is that then obviously everything that's been created before you're not gonna be able to take advantage of that. So say my NFTs do not benefit from somebody launching a new smart contract. But also these smart contracts, they're difficult to untangle, difficult to understand. And if you've got like 3-4 competing alternatives and you're an artist, and it took me 2 hours, right, to disentangle how the smart contract for Tim Berners-Lee, how that contract worked. And then if you're on super rare, if you use another contract, then you're migrating away from that platform. So yeah, so it can get pretty messy pretty quickly to start trying to solve this at the smart contract level. So for us, the solution came from two insights. One of them is philosophical, and one of them is technical. So from a philosophical perspective, the insight is that the NFT is not actually the artwork. So all the NFT is a certificate of ownership that gets passed back and forth. And there's no point trying to jam your artwork right into unless your artwork's like just simple, just like a GIF or an image or a single low resolution video, then it might work. But if it's anything more complex than that, and as I said, like the vast majority of the art outside of NFTs is generally much more complex. Then you're just going to end up massacring your art to try to squeeze into that. So just treat it as a certificate, and then develop the art in a fully expressive parallel state. And that is where the artist has complete freedom to decide what to decide and to describe and to secure what the art is, and have that parallel state being inextricably tied to the NFT. So that's all very well said, and that's all very well, but how do you actually pull that off? So that's where the technical insight came in, where all NFTs, so all NFT contracts, ERC 721s, ERC 1155s, they have a function called self-transfer. Safe transfer from. And the parameters for that function are a from address, a to address, and a token ID. So those are the three ones that normally get used. And then there's a fourth parameter in there called the data parameter. And sorry, I should have screenshotted it here, but I didn't put it in here. But that fourth parameter is the key to unlocking this parallel state. Because in that fourth parameter, the data parameter, you can pass it any arbitrary string. Sorry, it has to be in bytes, but you can pass it any arbitrary data. And that's what we use to construct this parallel state. So we pass a carefully constructed data package where we then describe on chain what the artwork is. So what you're looking at here is an actual live example of an artwork by an artist called Jenna Sutila. So we created the token. And then in the parallel state, we created a data package, which I'll show you shortly because it actually relies very heavily on IPFS. We pass a data package where we describe the artwork, and it includes a 1.8 gigabyte ProRes version of the artwork, which doesn't fit into the super NFT. And then we define a valid KSPEC transaction as a transaction where Jenna sends the NFT to herself. And so that records the data package on chain, and then she sent us the NFT. Then imagine, right, like in 6 months' time, Jenna comes up with like a cool idea about adding like a 360 version video, so like a VR version of the video. What we would do is we would send the token back to Jenna. And obviously, there are non-custodial ways of doing this, but at the moment, we're just manually doing it, right, where we send the NFT back to Jena. And then she burns, an updated data package. So that will, again, this is all on chain, and that will add the additional asset to the NFT. She does a self-transfer to record that, and then she sends it back to us. So, if this were, for instance, like a 3D avatar and, some new platform had emerged, or file formats had moved on, then as an artist, you're not too stressed about that because you can always, update the parallel state. And it's also much more expressive. You can express whatever you want in that state. So I'll go through a quick demo. We've got a quick, as I said, we launched on Wednesday, and we've got a quick demo application. So Anima and Marigold, they actually created this music video. So this is the first full resolution, full length NFT of a music video that we used KSPEC for. And what I'll link to now is our demo application, which is we've called IDDQD. You can pass it any NFT smart, so any 721 or 1155 smart contract and a token ID, and it's going to read directly off chain whether it finds any valid KSPEC data package. So in this case, it found one. And you can see here that we've defined a KSPEC as having three components. This just described what kind of KSPEC it is, and this is a header. And then the body is where we actually store the metadata and the actual data. So there's one area that I'll just quickly take you to, which is the credits, because this in and of itself is a collector. I personally find this super excited. So what you're seeing here, this is Anima's address, and this is Marigold's address. So immediately here we can see that they're both signing this, and actually in the header, I won't go into the detail in the header, you can actually see a hash confirmation, a signature confirmation from Marigold, who's the co-author. So here you already have a system for multiple people attesting to the provenance of this. And if you go to if you follow that transaction, actually here in our application, if you type the path parameter ID at the end, it'll actually take you to who made this NFT. And again, all of this is on chain. And here, let me inspect the second result, which is Marigold. And we'll go all the way to her records. I mean, there's metadata on her identity, which I won't go into, but you can explore. I'll link this. I'll link this in the chat if you want to, if you guys want to explore that, everything that's in there. But just very quickly, I'll show you. Again, this is all on chain. So here in the storage, what we have is data replication. So we've got fallbacks. So we've got a centralized URL, which will facilitate fast sharing, but also decentralized alternatives. As I said, like IPF, it relies heavily on IPFS. Arweave we use as well, but anything bigger than a gigabyte really is not practical to use Arweave. So just click here just to quickly show what that looks like. So this is Marigold, reading her ID. So the beauty of this as a collector is I don't have to rely on say Sotheby's or even Super. Like I trust them, right, to verify this, but I can now verify this for myself on on chain. And even more importantly, machines, right, can pull this information without having to send an email right to Sotheby's and going like, hey, how did you verify that this thing is actually made by the person who made it, who says they made it, and also it allows people to use platforms like Zora or OpenSea to create these things and have like an inbuilt provenance chain. So basically, there's no reason for there to be fake NFTs now, basically, which is one of the big problems in these permissionless environments. Actually, so I think I've covered the storage component, right? But yeah, as I said, like you can go through and inspect this. I mean, there's a law packed in there. Let me see if there's anything quickly interesting. Oh, one thing that's interesting here is that, we've defined like a distribution element. So, that pulls things from storage as required. So again, like if there's some new application that emerges that requires a particular format for the NFT to be ingested, you can just define a new element here, that serves that particular applications with, it could be like Decentraland or spatial or something like that. So every NFT, that has like, you can define like an arbitrary number of records, and you can also define an arbitrary number of components to the artwork. So I can leave some, I'll leave it there, but if there are questions as to this actual structure, we can cover that. I think no, here it is. Okay, so as I said, we launched on Wednesday. So what's next for us is to, at the moment, we're implementing these manually in collaboration with platforms and selected platforms and selected artists. But we want to put this in everybody's hands. So first step is developing docs. We then need to create a graphical user interface to sort of broaden the number of people that can actually use this. We need to build applications. So for example, like what this enables is like cross-platform stat aggregators and sort of attribution as well, which is a big problem right now, where if you're a minter and you have a collaborator, the minter is going to get the stats for the sale, which has a big impact on artists' earning capabilities. So those are the things, building applications. We've got a fantastic team of engineers working with us. We're looking for help as well to help build out this protocol, because we're going to need a lot of hands. We're already seeing a ton of demand, and we've been warned, by some platforms that to get ready to scale up, because we're seeing a lot of demand from the artists and the collector side. I'll pause there, and Luke, thanks a lot for the opportunity.
Of course, we're happy to have you. We're excited for the launch, and sort of following up on that. I know you mentioned there's been a positive reception so far, but how have things been going? I mean, you just launched. I guess for some of the hackers here who are interested, what could you use specific help with, or potentially what could they use this tech for in their projects going forward for the next 3 weeks?
So we're trying to work that out ourselves. I mean, I think we're going to start. I think any application, right, that sort of helps someone create this data package. Like imagine an artist, right, that doesn't know how to handle JSON, doesn't have like Hashdeep or whatever installed in a command line. An application that would construct this, validate the schema for it. That would be something super interesting, and that artists would find. Because what we're seeing right now, right, is we've got a ton of artists who are DMing us with like the stuff that they haven't been able to create because they were facing the limitations that they did in NFTs, and they're saying, how do I create a KSPEC? And the best I can tell them is like, okay, we're going to get you docs like soon, very soon. So anything that can help them create this thing for themselves, I could basically give you like a list of 10 people who would be ready tomorrow to start implementing it.
Mm-hmm. That's excellent. Yeah, there's been so much expansion in the NFT space, specifically over the past year. I think everyone, like the question on everyone's tongue is sort of like, what will be next? Where, I guess, do you expect things to be maybe next year in a perfect world?
Yeah. So, well, in a perfect world, all artists, we can even handle anonymous identities as well. We've got like an attestation system that we can use with this. So I think all artists have verified their identity on chain, and then for anything more complex than a video or a GIF, then creating these this structure for those NFTs on chain, and then that just opens up like a whole ton of possibilities. I mean, you could use it. I mean, you could use this for journals, for instance. I'd love to see this being implemented for academic journals, right? VR, AR. I would, okay, let me put it this way. I would love to see the complexity of the art just explode, and to be surprised to, like, in a year from now, going like, holy crap, like, how, we thought that 3D avatars were cool, and we thought that in a year's time, everybody would be like, have like their 3D avatars in an NFT, and which we're working on, by the way. But being there in 12 months ago, like, yeah, we did that, but this other thing that we just never saw coming, that would be pretty cool.
Yeah, there's just a myriad of possibilities. A sort of super nuanced question for you here. If you could explain for us in the call right now how the parallel state works.
How the parallel state works. Yeah. So by parallel state, we basically mean a state for the artwork, right? So at the moment so this is a token, right? So token 26090 on super rare. So that's a real token, and this all exists right now. The state of the artwork at this point includes a 50 megabyte file, which is a low res file used for serving on the internet, and it includes a ProRes, almost 2 gigabyte file. So you can think of it as like, how Ethereum's a state machine, right? So at any particular point in time, it's like a snapshot of what the data is. So that's what we mean by parallel states. At this point, this is the state of the artwork. Then if you want to modify that, KSPEC has like permissioning built at the lowest level, so that, for instance, like I can't just like modify this myself. So the way we enforce that is by defining a valid KSPEC as one where the artist has to send the artwork to herself. So say if K21 sent this to themselves, it just would be ignored by the protocol. But because here she sent it to herself, we know that both K21, which is our collection, and the artist consented to this updating of the artwork. So here, this was the state before, and this is the state now, and the new state includes an additional file. So I don't know if that answers the.
No, that makes sense. I appreciate the definition being pretty synonymous with the syntax chosen. As far as next steps for you guys, I know you've sort of mentioned what your plans post rollout are. Maybe delving back into that a little bit for KSPEC. You've got the applications you're hoping to build, and if you could just, I think, go a little bit further into that for people who are still with us, I'd be pretty interested to see what you're working on.
Yeah, sure. So, I mean, you could always take it step by step as where we're going. So, I think first we're going to start with an application that allows people to create their KSPEC IDs, because those data packages are very standardized. That's a good place to start, and also it also helps artists prepare, right, for when they have a project, because you require a KSPEC ID to create a valid KSPEC. So an application, we've got a product designer, right, and so again, we launched this on Wednesday, so we haven't really exactly defined how that looks like, but our product designer is fantastic, and we'll come up with a great UX, right, for creating that UI. Then I think the next step would be creating a UI that tackles like the 90% use case, which is that artists run into this like 50 megabyte, 100 megabyte limit, and what they actually want to do is like they want people to experience a 3 gigabyte a 3 GB file on an LCD screen, whether it's at a gallery or in the collector's home. Yeah, so there we're talking about actually constructing, a graphical interface for constructing a standardized KSPEC. So I think there's always going to be like room for someone like Kanon, but it doesn't have to be just us, but someone like Kanon creating like these more bespoke ones. Like we did one, for instance, for a website, that the artwork is actually like an entire self-contained website, right? So that takes a bit more thought, and those are going to be a bit harder to handle like in a standardized way. But 90% of the artwork is, at the moment anyway, right? 90% of artists will be able to use like this graphical interface and get their artwork done. And it also might serve as like a reference implementation for any platform that wants to just build that, sort of like build that into their own, applications. We also are quite interested in this idea of like matching collectors and artists. And then sort of like developing a non-custodial way of, because at the moment, as I mentioned, the permissioning system requires you to send the token to the artist. I'm not particularly concerned about, the security of that, because most of the time, right, the likelihood that like a legit artist is going to like run away with their own token, right, that'd be disastrous for them. But still, obviously for completeness, it'd be good to have like a non-custodial solution. But more than that, it's be able to do it asynchronously, I think, is important, and hence why I think if you've got that capability for the non-custodial, where someone could deposit the token and then have that performed at some point, and then that would be super useful. And then, as I mentioned, like. These applications that read sales statistics in particular, and this is something that artists have actually shared with us, right? That it's very difficult right now because each platform has their own way of tracking sales statistics, even though everything's on chain or should be on chain. But also things like, say in this Anima video. This is a collaboration between Anima, who's the music artist, and Marigold, she's the visual artist or the 3D animator. And Anima minted the work on Super Rare, and he received the credit for whatever it was, like 21 ETH or something like that. And Marigold did not, like on the platform, she did not. There's no way for Super Rare at the moment, right, to make that attribution. Because the credit is provided like in the description. This is not machine readable. But with KSPEC, it's completely machine readable because it's very well structured and defined. And so it's cross platform, so you'll be able to. So that's one application we're very interested in because it directly helps artists to have somewhere where they can show the track record of the sales and everything, which is super critical to what they can expect to get for subsequent works.
I love it. I can immediately see the value for the creators going forward, and especially in this sort of decentralized economy. That's going to be incredibly important. I want to thank you for presenting today and showing us everything that you've been working on. I'm really excited for your team, and really, I guess we can also, we're proud of the developments being made on your side. So thank you again for all of your time today.
Appreciate it. Thank you very much, Luke. Thanks everyone.